What we're looking at today is graphing hyperbola. Now, what I want you to do is take a moment about the basic hyperbola 1 over x. Jot down everything that you can remember, everything that you know. If we have a look at the hyperbola 1 over x, we get this graph here. What you need to remember is that we have two asymptotes. So asymptotes where the graph approaches the line but doesn't actually cross over. So we have one at x equals 0 and we have another one at y equals 0. This is the basic graph that we are looking at today. Now our first question is sketch the graph of y equals -3 over x. So we are going to be manipulating that very basic hyperbola. Now what you'll notice here, I've taken the hyperbola 1 over x and I've put 2 points on there. So I've put 1, 1 and 1, -1. The reason that I've put those there is so that we can see how this change affects the graph. Now, if we take any function, multiplying that function by a negative will cause a reflection in the x-axis. So -1 over x will look like this. Now if we put the 3 there, that's going to give us a vertical stretch because we're multiplying every y value that's achieved by 3. And if you have a look at those 2 points that I've shown you, you will see that -1, 1 has gone upward to -1, 3, and 1, -1 has been stretched downward to 1, -3. Next, we're going to look at the graph of y equals 1 over x plus 2. Now again, we're still looking at that basic hyperbola of 1 over x and how adding 2 will affect it. So by looking at the point -1, -1, if we add 2 to that, we will get at x equals -1, y equals to 1. And so what it has done is it has translated upward by 2 units. And so it looks like this. What you need to make sure of is that you have also translated your asymptote. This is very important when you're graphing hyperbola, that you are putting in the asymptote correctly as well. Now, you'll notice that it also crosses the x-axis. So we need to find that value. We take y equals 1 over x plus 2. We know when the hyperbola crosses the x-axis, then y is equal to 0. So that's what I'm going to do. I'm going to let y equals to 0. That will give me 0 equals to 1 over x plus 2. And we subtract 2 from both sides, so we're now solving this equation for x. We want to isolate that 1 over x by subtracting 2 from both sides, which gives me -2 equals 1 over x. I'm going to multiply both sides by x to give me -2x equals to 1, and divide both sides by -2. We know that we get x is equal to -1/2 at the point where the hyperbola crosses the x-axis. This gives us an x-intercept of -1/2, 0. Now on the third one, we have y equals to 1 over x minus 4. So again, we consider our initial graph of the function y equals 1 over x, or fx equals 1 over x. We can see that where there was an x on its own is now x minus 4. This translates to a movement of the graph to the right by 4 units. And so again, remembering to transfer the asymptotes to the right, we've transferred each of those points that I've put on there to the right by 4 places. This gives us a y-intercept at x equals to 0. So I've already graphed the intercept there, but how we calculate that? So to find that y-intercept, we're going to let x equal to 0 and solve for y. So that will give me y equals to 1 over 0 minus 4, which will give me y equals to 1 over negative 4, or negative a quarter. So my y-intercept is 0, negative a quarter. I hope you found this video helpful.